edge networks and secure traffic management. Welcome to this lesson on edge networks and secure traffic management. The growth of cloud computing, IoT devices, and mobile technology has shifted network processing closer to the edge, closer to where data is generated. Edge networks help reduce latency and improve performance, but they also introduce new security risks. Managing traffic securely at the network edge is essential for preventing cyber threats and ensuring reliable communication. In this lesson, we will explore edge networks, their security challenges, and best practices for securing edge traffic. Let's get started. An edge network is a decentralized computing model where processing happens closer to the user or data source rather than in a centralized data center. This reduces latency and improves performance for applications that require real-time data processing. For example, a self-driving car cannot wait for data to travel to a remote cloud server and back. Instead, edge computing allows processing to happen within the vehicle or at nearby edge data centers to make split-second driving decisions. Edge networks also power modern services like content delivery networks, CDNs, 5G networks, and IoT devices, improving efficiency while reducing bandwidth costs. Here's how to secure edge networks effectively. Encrypt data at rest and in transit to protect against unauthorized access. Deploy edge firewalls and intrusion detection systems, IDS, to monitor traffic. Enforce strong authentication for devices connecting to the edge network. While edge networks improve performance, they introduce several security risks due to their distributed nature and exposure to public networks. One major risk is an expanded attack surface. Traditional networks rely on centralized data centers with tightly controlled access. In contrast, edge networks distribute computing power across many locations, making them harder to secure. Another challenge is the risk of unsecured IoT devices. Many edge devices have weak security controls, making them targets for hackers. If an attacker compromises an edge device, they may use it as an entry point to launch larger attacks. For example, in 2016, the Mirai botnet exploited vulnerable IoT devices to launch one of the largest distributed denial-of-service attacks in history. This attack disrupted major websites by flooding them with malicious traffic from hacked edge devices. To prevent such attacks, organizations must apply strong security policies and continuously monitor edge network activity. Here's how to address edge security challenges. Implement zero-trust access controls for all edge devices and users. Apply regular software updates and patches to edge systems. Use network segmentation to isolate edge networks from critical systems. In network security, ingress refers to incoming traffic entering the network, while egress refers to outgoing traffic leaving the network. Controlling ingress and egress traffic at the edge is crucial for detecting threats and preventing data leaks. Without proper controls, malicious actors can exploit edge devices to inject malware or exfiltrate sensitive data. For example, a retail company using edge computing for real-time sales analytics must prevent unauthorized access to its POS systems. If an attacker gains ingress access, they could manipulate transaction data or steal customer payment information. Similarly, egress controls prevent insiders or compromised devices from exfiltrating sensitive data. To mitigate these risks, organizations must apply strict firewall rules, encryption, and data loss prevention (DLP) measures. Here's how to manage secure traffic flow at the edge. Deploy next-generation firewalls and GPUs to filter edge network traffic. Use data loss prevention (DLP) tools to block unauthorized data transfers. Monitor ingress traffic for anomalies that could indicate an intrusion. The rise of 5G and the Internet of Things, IoT, has expanded edge computing, enabling smart cities, autonomous vehicles, and industrial automation. However, these advancements also create new security risks. In 5G networks, massive numbers of devices connect to the edge, making it easier for attackers to exploit unprotected endpoints. If one device is compromised, malware can spread rapidly across the network. Similarly, in IoT environments, many devices lack built-in security controls. Hackers often target weak passwords or unpatched vulnerabilities to take control of IoT devices, using them for spying, DDoS attacks, or data theft. For example, an attacker could hack an IoT security camera at a corporate office and use it as a backdoor to access the company's network. To secure edge networks in 5G and IoT environments, organizations must implement network segmentation, strong authentication, and AI-driven threat detection. Here's how to enhance security in 5G and IoT edge networks. Use AI-driven threat detection to identify suspicious behavior in real time. Enforce device authentication before allowing IoT devices to connect. Implement micro-segmentation to prevent IoT devices from communicating with unauthorized systems. Let's look at a real-world example of how edge network security is applied in a smart city. A metropolitan city deployed an edge computing network to support traffic monitoring, smart streetlights, and public safety cameras. These devices processed real-time data at the network edge, improving efficiency and response times. However, security concerns arose when researchers discovered vulnerabilities in some of the connected devices. If hackers exploited these vulnerabilities, they could manipulate traffic lights, disable security cameras, or gain unauthorized access to city databases. To mitigate these risks, the city implemented a multi-layered security approach, including encrypted communication between devices, AI-driven threat detection, and strict access control policies. As a result, the city secured its edge network infrastructure, ensuring the safe operation of its smart city services. Here's how to secure large-scale edge networks. Encrypt all data transmitted between edge devices to prevent eavesdropping. Use endpoint detection and response (EDR) solutions to detect compromised devices. Deploy AI-driven monitoring tools to analyze network traffic for threats. Now, let's summarize what we've learned about edge networks and secure traffic management. Edge networks reduce latency and improve performance by processing data closer to the source. Security risks include expanded attack surfaces, IoT vulnerabilities, and unsecured ingress-egress traffic. Strong firewall policies, encryption, and network segmentation are essential for securing edge networks. 5G and IoT environments require enhanced security measures, including AI-driven threat detection and authentication controls. Organizations must continuously monitor edge network activity to detect and mitigate cyber threats. By applying these security best practices, organizations can safely adopt edge computing while protecting sensitive data and critical systems. This concludes our module on edge networks and secure traffic management.